Welcome back to part 2 of evaluating this triple integral over the region E, where E is the solid tetrahedron defined by these four vertices. In part 1, we determined the order of integration given by dy, dx, dz, and the corresponding limits of integration. In this part, we want to evaluate this triple integral. So we first integrate with respect to y, treating z as a constant, and therefore the antiderivative is going to be z times y. I now need to find big F of b minus big F of a, so we'll perform substitution for y. So we're going to have z times the quantity 3 minus 3/5 x minus 3/2 z minus, when y is 0, of course we have 0. Notice how the new integrand function is going to be 3z minus 3/5 xz minus 3/2 z squared when we distribute z. And now we integrate with respect to x, treating z as a constant. So the antiderivative is going to be 3z times x, or 3xz, minus 3/5 z times x squared divided by 2. Let's write that as times 1/2 x squared z, and then minus 3/2 z squared times x, or minus 3/2 x z squared. Now we need to find big F of b minus big F of a by performing substitution for x. This is where things start to get messy. First we substitute 5 minus 5/2 z for x. So here we'll have 3z times x, which is 5 minus 5/2 z. And then we have minus, this is going to be 3/10. We have z, and then x squared becomes the quantity 5 minus 5/2 z squared, minus, here we're going to have 3/2 z squared times 5 minus 5/2 z. And then when x is 0, each term has a factor of x, so we'll have minus 0. So now we'll go ahead and distribute here and here, and then square the quantity 5 minus 5/2 z. So distributing here, we're going to have 15z, and then minus 15/2 z squared. Here we'll have minus 3/10 z times, when we square 5 minus 5/2 z, we're going to have 25 minus 25z plus 25/4 z squared. We'll still have to come back and distribute here. Then distributing here, we're going to have minus 15/2 z squared, and then we have plus 15/4 z cubed. And now we still need to distribute here and then combine like terms. So here we're going to have negative 75/10 z, or minus 75/10 z, and then plus 75/10 z squared. And then we're going to have minus 75/40 z cubed. And we still have minus 15/2 z squared plus 15/4 z cubed. We now need to combine like terms. We have two z cubed terms here and here. We have three z squared terms here, here, and here. And we have two z terms here and here. So you may want to check this, but this does simplify to 15/8 z cubed minus 15/2 z squared plus 15/2 z. And finally, we integrate with respect to z. So the antiderivative is going to be 15/8 times z to the 4th divided by 4 minus 15 halves times z to the third divided by 3 plus 15 halves times z squared divided by 2. So first, when z is 2, let's write this as 15 30-seconds times 2 to the fourth minus, here we can simplify. There's 1 3 and 3 and 5 3s and 15. So we'd have minus 5 halves times 2 cubed plus, this would be 15 fourths times 2 squared. And then when z is 0, notice each term would be 0. So simplifying here, this simplifies nicely to 5 halves, which equals 2.5. So there's quite a bit of algebra here in order to evaluate this triple integral. I hope you found this helpful.